Good afternoon and welcome to today's Roads and Bridges webcast. Our topic is AI in transportation, shaping disaster recovery, compliance, and sustainability, sponsored by the American Traffic Safety Services Association, aka ATSA. I'm Gavin Jenkins, Senior Managing Editor of Roads and Bridges, and I will be moderating this session. Before we dive into today's presentation, let me explain how you can engage with us during the session. If you encounter any technical issues, please type your concern into the Ask a Question box on the right side of your screen, and a member of our team will assist you. We also encourage you to submit your questions throughout the event. We will address as many as possible during the Q&A session after the main presentation, but feel free to send in questions at any time using the Ask a Question box. Lastly, please note that today's session is being recorded and will be available on the Roads and Bridges website within the next week. You will receive an email notification once the recording is live. Now it is my pleasure to introduce our speaker. Mark Pittman is the founder and CEO of Blyncsy. He is passionate about improving the world through technology and innovation. Prior to his current role, Mark worked in areas as diverse as political campaigns, law firms, startups, and even a Fortune 500 company. Mark is the Director of Transportation AI at Bentley Systems. It's so exciting to have you here with us today, Mark. So I will go ahead and I will turn things over to you. Mark, the floor is yours.
Well, thank you guys. I really appreciate the opportunity to be here today. Thank you to ATSA, Roads and Bridges, and Gavin, of course, for that lovely introduction. Really excited to talk about this topic for a couple of reasons. One, as you'll get to know, hopefully in the next few minutes, I'm incredibly passionate about our transportation system and the power it has to impact and shape the lives of everyday people. Whether it's you're going to work, going to school, getting your groceries, the transportation system is what allows us to abide by our way of life, and using new advanced technologies to accelerate how we shape everything from disaster recovery and compliance and to support sustainability, of course, is at the core of what we as innovators and entrepreneurs are striving for every day to build and create. I started Blyncsy just over 10 years ago with the sole focus of building a smarter, safer transportation system through cloud computing and AI-based technologies. Really excited to kind of dive into what that might look like from a vision perspective. Over the last few years, we've seen a rapid increase in cameras on our roadway infrastructure. Right? AI vision, computer vision technologies is how a Tesla drives an autopilot. It's how your new Subaru might use its lane assisting technology, ADAS system, to identify where the lane is, how far the car is away from you in front of it, and what that adds to our roadway infrastructure system is a layer of safety that's never been available before. Cars can now keep themselves in their lane, keep the distance of the car in front of them, but this also creates this massive opportunity that we found to help support AI in the transportation system. So think about the dash cam, right? The humble dash cam, as I like to think of it, this little device you can see here on your screen. This technology is very readily available, very inexpensive, something you can buy off Amazon. And you can put in your car and it will record your roadway drive as you go down the roadway. This helps you from an insurance perspective. And of course, it's also just kind of interesting to see and understand what this camera might be capturing in your day-to-day. What we as humans take for granted that we see through our eyes and make sense of with our brain as we go about our day, this camera is now able to do in near real time perpetually as the vehicle drives down the roadway. So these cameras are constantly recording the road infrastructure, right? And they're collecting imagery in nearly 30 frames per second. So that's 30 images every second that they drive down a roadway. This is full 1080p HD resolution. Some cameras even record in 4K. And now we have the ability to connect these cameras to a technology via cellular or internet uploads to your cell phone to make sense of this data in near real time. So imagine these cameras, millions of them on the roadways in semi-trucks, delivery vehicles, Uber and Lyft, even in your own passenger vehicle, now helping to understand and analyze our road infrastructure just as you go about your everyday. It is an incredible technology. And I like to think about it as the core deliverable around connected vehicles. For years, we've been talking about how cars will talk to infrastructure and infrastructure will talk to cars. And we've always had this question of, well, how? When will vehicles get equipped with this technology? How will we equip the intersections with it? what's the breaking point and what's the commercially available market application to get this live? Well, the dash cams are out there today, and you're putting them in your car for insurance safety reasons. Commercial vehicle might be putting them in to make sure that their drivers aren't drunk behind the wheel, to ensure that no one's backing into their vehicles or stealing packages, a variety of reasons. Now, these cameras are collecting imagery. Now, making sense of that imagery is what's really, really crucial. So our technology is really focused on using these dash cams to pull that data out and make it useful to us. Cloud computing has really enabled a variety of new use cases to use AI, computer vision applications to make sense of imagery in perpetual near real time. With over 1 million vehicles connected to our network, we are constantly pulling up a stream of these images. Around the world, in perpetual, consistent real time, we're understanding what it's like to drive down the roadway, whether you're grandma in a Buick or Elon in a Tesla. We see the roadway the same way you do as a driver, from a head-on view right out of the windshield. AI models can be trained on this imagery and have been trained to identify everything from guardrail defects, vegetation encroaching on the road, debris, work zones, and a variety of other circumstances that we'll kind of talk about. But really the crucial thing here is a lot of data is not always useful. You've got to deliver actionable insights. How do you make sense of what's going on? And disaster recovery, compliance in particular, offer really interesting opportunities to make our roads safer, particularly in high-risk environments like responding to natural disasters, and of course to also understand what our road infrastructure is designed to do and whether it is currently doing that for the road users that are on the road infrastructure today. So what does this technology detect? You've told us a little bit about the dash cams, Mark. I get AI is kind of analyzing these images, but like, what are you seeing and what are you doing with it, right? So this is really the crucial part of this technology. And we make sense of so many things, and the list keeps growing. So you can picture really simple things, right? If you drive through your neighborhood road, you might see cracks in the pavement, you might see a pothole in the winter. If you live in a snow state like I do, we're expecting the snow plows and the heavy salt to hit the ground here in the next few months, and that start to have an impact on our infrastructure. But we're also seeing that this is getting impacted more and more, right? Weather's getting more extreme. Electric vehicles are heavier. We're getting more commercial delivery vehicles on our roadways. The pavement and the roadway itself is getting worn, beaten, and battered more than ever before at a faster rate. We're seeing potholes develop faster. We're seeing more cracks in our roadway. We're seeing the pavement markings wear down quicker as hotter temperatures, wetter environments, and more vehicles start to wear down those paint lines. All of these applications are really crucial to our everyday. Our roadway infrastructure system is one of the most valuable pieces of infrastructure we own, and without it, our way of life effectively ceases to operate. From the clothes on your back to the food that ends up in your fridge from the grocery store, all of it relies on the infrastructure system. Making sense of it is the crucial element here that we focused on. So these applications are to detect the specific crack on the road, the type of crack, how many cracks might exist in a 50-meter segment, a 100-meter segment, how often are those repeating, and where are they at? These types of ways to think about this technology are really crucial from an infrastructure perspective and allow us to make sense and understand of what this looks like. Active transportation is another use case that we think about really crucially here, making sense of the understanding of how our road infrastructure is being used. It's not just cars and other heavy vehicle users, it's also the pedestrians that are crossing the crosswalk, it's the bicyclists using the bike lanes, or driving down our roadways, period, right? We want to make sure that we can understand how much paint is left in a crosswalk. If the street light is out at that crosswalk and the paint is heavily faded, we know there's a high risk for a pedestrian safety collision at that event. These types of applications accrue faster and faster. And of course, the beautiful part here is one picture, one image of the roadway can be used to analyze 15 to 20, maybe even 50 different applications and use this technology in a more scalable and active way. Signs are a really core and a critical piece of this technology for both human and automated drivers alike. If you don't know where the exit sign is, you're not sure where the off-ramp is. Neither is an autonomous vehicle. But one of the critical applications here is knowing that the sign is in good repair and where it's at. Speed limit signs are at the top of the list here. In a disaster recovery type environment, say a hurricane or a tornado, signs are knocked down, damaged all the time. Safety critical signs such as stop signs and yield signs, if they're missing at an intersection, there's a high likelihood that someone will blow through that stop sign or what was that stop sign at some point and get in a collision. These types of things are really crucial and critical to our way of life. So AI allows this technology to make sense of signs. We can detect the presence of a sign on the road. We can determine if that sign has been damaged, If there was a sign here yesterday that's gone today, if the sign is visible during the day, if the sign is visible at night, and which specific MUTCD sign code this sign has. What sign do I have here? What should I have here? And where is it at? These types of applications are recurring needs. Why? Because an autonomous vehicle sees the roadway infrastructure this exact same way. It's looking for advisory speed limit signs. It's looking to understand where the lane's going to end. It needs to know where the stop sign and the yield sign is. It needs to know where to exit, the same way you do as a human driver. And this is the really powerful opportunity to connect all of these applications together. The vehicles driving our roadways today are collecting this data through a dash cam, using that technology to make our roads safer and smarter by partnering with local governments and state departments of transportation allows the road infrastructure to become smarter and safer for those people who drive on it. We are building a transportation system for our drivers. They now have a chance to report that data back in near real time to identify opportunities for fixes and repairs as we go through our everyday. Work zones are a really crucial part of this story. Why? Because you need to know what's going on, where it is, and what's going to happen. Knowing what's ahead is a crucial element for road safety. We see traffic fatalities in our work zones all of the time. They have a high risk of injuring workers and the traveling public at the same time. If the barrels weren't put on the ground appropriately, if someone knocked down a bunch of them, if the taper and the spacing are incorrect, if the incorrect MUTCD signage was not appropriately placed in advance of the work zone, how do you know what's coming at you? How do you know what to expect? We are building a system that needs to be more algorithmic. We need to be able to know and prepare that on a 70-mile-per-hour road, on a 6-lane highway, we know what it's going to look like if there are lane closures in place. And the powerful application here is to make sense of things that move and change quickly. This technology is available in near real time. You can buy an image from a dash cam like this within 60 seconds of a vehicle passing by a given location. If you're in the construction side of the business or you're managing permits, you have the ability to see in near real time what it's like for a vehicle to drive through your work zone, to see if barrels got hit and got knocked over, to make sure your contractors open the lanes and close the lanes appropriate with the management of traffic plan that you've got. These applications are crucial because they allow us to communicate this data out now to a broader public. We applaud FHWA for announcing and releasing and supporting the Work Zone Data Exchange, the WZDX data feed. Why? Because it's the first national application where any state, any city can participate by contributing the presence of work zones and lane restrictions to a work zone data exchange that anyone can make sense of. Google Maps, Apple Maps, autonomous vehicle providers, anyone can subscribe to this data feed free of charge. It's managed and maintained by the federal government on your behalf and make this data available. Imagine if Google Maps knew every work zone, if the lanes were closed, when they were going to be closed in advance of you driving there. Your routing could be smarter. You would know in advance what's going to happen in those areas. And for large delivery vehicles in particular, think semi-trucks who are planning their routes in the most fuel-efficient way, there might be massive opportunities to support sustainability. Of course, it also supports us on the compliance side. Why? Because the MUTCD has set up an entire section governing how the management of traffic should occur in a work zone, making sure that your traffic control plan is written according to spec is a critical element. Ensuring that it is compliant during your work zone protects you from liability and protects the traveling public as they go through those work zones. So really crucial applications to use this computer vision technology to tie these things all back to themselves. And now we get to one of the most interesting use cases, which is disaster recovery. We know that when disaster strikes, we need to be ready to take charge. And we really have a core application here to get our infrastructure system open and operating as quickly as possible to support the recovery efforts after the fact. How can you use this technology in the before and after use case for disaster recovery? We're going to highlight two use cases here. One is the first one in the state of Hawaii. We've been fortunate to partner and work with the state of Hawaii for over 2 years now, analyzing all state roadways every week. Our technology was analyzing the roadway infrastructure around Lahaina prior to the wildfire, and within 3 days after the wildfire event, we'd collected new imagery. Yeah, you'll see that in the top two images here, the before and the after, the understanding what infrastructure was there before, what condition it was in. This is really crucial if you're applying for ER funds from FHWA or FEMA disaster recovery funds. You need to demonstrate that the infrastructure was there, what condition it was in to qualify for reimbursement for that infrastructure. A picture is worth 1,000 words for a variety of reasons, but it's very powerful when it can be working in the background to expedite your FEMA reimbursement funding and get you the resources that you need while you're out there responding to the disaster itself. These types of applications are really crucial also during hurricanes. Most recently, during our last two hurricanes, Milton and Helen, we saw opportunities to use this technology to identify where roads might be closed through hazards. Tree branches have fallen, power lines have gotten knocked over. How can you see in near real time in your traffic operations center what's going on in your infrastructure? You can now with the power of this computer vision technology. These vehicles that are out there already driving these roads, looking for a way to get from point A to point B, are collecting this information, whether you know that those roads are closed or not. Now you have the ability to make that data available to everyone, whether through the Workzone data exchange or similar, or through your traffic and traveler information systems. Knowing where to go is the crucial element. Never before have we had such resource constraints in the public sector. We have more roads to manage than ever before. We have more demand for our resources than ever before, and we have fewer humans to do the work. Making sure that we deploy a human to the right place at the right time to fix the right thing. And so they know in advance what it is that they're tackling, saves time and resources, and also ensures the safety of those responding to the event. We don't want to put people on the roadway when they don't need to be there. We want to make sure that when they're on the road, they're providing the highest value and best service, not putting themselves in harm's way, looking for problems, rather responding and fixing those problems. This all takes us to the big glorious issue of compliance, right? Federal regulation in particular puts a lot of work and a lot of burden on our local governments. And there's value in them. But making sure that we can do that in the most succinct and sustainable way is, of course, really, really crucial. From a compliance perspective, we see a variety of really interesting opportunities to use technology like this. Whether you're doing things like the Meyer data reporting, looking for model inventory of roadway elements, reporting back to the feds, say, for example, through your federal aid road projects, whether or not you can prove that you put a sidewalk in with federal aid money or put in a stop sign. Today, DOTs and cities across the country are sending folks out with a digital camera or an iPhone, taking pictures, going back to their office and uploading those images as proof. That data is available. It already exists today, and it will be available to you from the power of your desktop from your computer. These types of applications are really crucial as we think about HPMS reporting in particular. All 50 states are collecting their HPMS data in slightly different ways. It becomes very challenging for FHWA to take these data sets and compare them. How can we compare West Virginia to California if they're using different methods of collecting that data? Maybe one's going out and surveying it by hand, another using LiDAR, one's using computer vision or other technologies. It's very hard to match these apples to apples. How do we understand the breadth and scale of our transportation system? This technology is collecting all of our major roadways across the entire country, whether we know it or not. Already today, using this technology at a fraction of the cost to collect this data ubiquitously allows us to compare apples to apples nationally and think of our transportation system as a true transportation system, not a disconjointed network connected by different states and local entities. Jurisdictions don't start and stop for the traveling public, even if they do for us on the government side. Thinking about the system as a true network allows us to focus in that way. We've talked at length about the MUTCD and how crucial and important it is using the MUTCD as the model and the guideline to understand what your infrastructure should look like, and what it looks like today will keep you safe from a liability perspective and avoid frivolous lawsuits, but of course also ensure the traveling public is safe when they drive on their roadways. Using computer vision technology and using the power of AI to make this technology available to you allows you to get eyes on the road anywhere, everywhere, in near real time, and report to you where you need to be, when you need to be there, and what you need to fix to get things up to spec. Autonomous vehicles are coming. We've been hearing this for a long time, and some version of it is already here today, right? You could go out today to almost every new car manufacturer and buy a vehicle with cameras in the front of them. Computer vision has become the default. Whether we like it or not, it is where we are today. Why? Because at the end of the day, we are all striving to use technology to replicate the human brain. The human eyes see the road infrastructure. The human brain makes sense of it in a very complex and intuitive way that we've come to rely on. And for decades now, humans have been trying to replicate the power of the human brain using cameras and computer vision technology. And we are now approaching a world in which that might be soon possible. We're not quite there yet, but we're working every day to advance that technology. And autonomous vehicles will see the road slightly different than we will today. Autonomous vehicles see pavement markings different than we do. Knowing which paint line is visible at night or during the day is crucial. Knowing whether contrast markings, black and white markings are visible is a whole other question. We understand that white pavement markings use retroreflectivity today to understand how visible they are at night, but we don't have a metric to think about how visible they are during the day. What about driving into the sun at 2 in the afternoon? What about the black part of your contrast markings? What percentage of that paint is still on the ground today? Computer vision allows you to see the road infrastructure the way an autonomous vehicle would driving on it, and the way grandma would when she's driving down it today, ensuring that we're operating in a system that will eventually be mixed use, both human and automated driver alike. But for today, we're looking to enhance safety as much as possible. It is the name of the game. Improve safety, reduce maintenance costs, and most importantly, improve public trust. If the public is our partner, we can communicate with them effectively on where we want them to be, what behaviors we want them to engage in to make the system safe and extend the useful life of our assets. These two things are really crucial and really come together in this unique opportunity. We're excited about autonomous vehicles, right? The opportunity for efficiency is astounding, but only if we work together to achieve those goals. If you're driving down the freeway today and there's an exit lane, an off-ramp, and there's no dashed markings in front of that off-ramp, an autonomous vehicle might think that the lane has widened and it tries to center itself right before it crashes into an end treatment at that merge point. Ensuring really simple applications like this are available ubiquitously helps us understand how to accelerate autonomous vehicles and autonomy around our system. This becomes a really sustainable solution for state and local DOTs. Instead of spending $200, $300, $400 to do one-time LiDAR surveys of your roadway infrastructure that takes 6 months to collect and 6 months to process, this technology can be available in your inbox in an hour. You can reduce carbon emissions, you can extend the useful life of your asset, and you can make your data more efficient by using collection that's fast, intelligent, and focused. If you're in the business of understanding the condition of your sign visibility, you need someone to analyze that sign visibility for you. Now, you may have to partner today with 3 other divisions or 4 other divisions in your department who are collecting that data on a van. That might be a part of a larger data contract. And that makes it really challenging for you to do your job independently. Bringing down the costs, bringing the barriers down as much as possible and aggressively as possible allows this data to be ubiquitous. Open sourcing this data, open APIs and open data standards, and making sure the data is compatible with all other open data standards products is key to ensuring the success for our local and state DOTs. At the end of the day, all of this is possible because of the cloud computing architecture we have today. We are living in an incredible world. In my lifetime, we have gone from core paper infrastructure to where we are today. Design files were done manually, and to some extent still are today, but the majority is done in 3D, right? We are changing the speed and scale at which we make sense of this. Over 1 million vehicles are connected to my network alone today, 24/7, 365, expanding at over 300% per year. The API cloud architecture that exists today has a future open data standards built into it. Data should come from one system and into the other, be interoperable and be compatible. It should also be privacy and cybersecurity robust so that we can ensure the data is safe to use and safe to access. But really, at the end of the day, it's about the scale and speed of the infrastructure that allows us to do this. And without the cloud computing piece, artificial intelligence wouldn't be available. From generative AI, creating new images and making sense of things, to computer vision and what's called narrow eye, we're all heading towards the general AI future. The idea of a robot that makes sense of the world and can think like a human is on the horizon in the medium to long term. But today, we have specific applications and actions that we can take that are low cost, scalable, and efficient to implement artificial intelligence in our local and state DOT roadway infrastructure to make roads smarter, safer, and extend the useful life in disaster recovery, compliance, sustainability, and others. And with that, we'd love to open it to some questions from the audience. Yeah.
Oh, wow. Mark, that was amazing. Thank you so much. We really appreciate you sharing that insightful presentation with us today. And I just have to say, your passion was just leaping off the screen. And the fact that ATSA brought you here today just goes to show, because if there's one word that describes ATSA, it's passion, just passionate about safety. And I'm excited to see what questions we have here. Let's just jump into it. First question, let's talk about the federal regulations, which seem to pop up every year and put a strain on transportation agencies to comply. One of the biggest is the new FHWA minimum standards for paint retroflectivity, with cities and states having less than 2 years to be in compliance. How do you see these regulations affecting transportation agencies, especially budgets and operations, in the near term and in the years to come?
Yeah, it's a really, really good question, a really powerful question too, with a large impact across the entire country. Starting in 2026, FHWA has a new rule that came out that requires all roads with speed limits of 35 miles per hour or higher to, perform a minimum paint line visibility analysis and come up with a plan to manage minimum visibility on those roads. For the first time, this will now impact all local roads and state DOT routes. Many of our DOTs and cities today at the cutting edge of this have been doing a random survey of their roads today, right? They may take 1 or 2% of their roadways, go and do a retroreflectivity analysis on them and extrapolate that data out to the rest of their system. Now, 100% of their system has to be analyzed. There's some opportunities to use federal regulations, though, of course, to make this smarter, safer, and more efficient. Now, the true cost of sending someone out with a retroreflectivity van to drive the entire roadway network in the whole country is staggering. In fact, for most local governments looking at it today, they're wondering how they're going to do it. Are they going to drive around with a truck and have someone sitting in the passenger vehicle at 9 p.m. at night saying whether or not they think the lines are good enough or bad enough? Are they going to pay a vendor tens of thousands of dollars to drive a van? Will there be capacity? Will there be scale? Will that even be available? How will we do that in time? Have we budgeted for that? These things, these are huge questions. And we see a real big opportunity to use computer vision. Why? Because again, we understand the exposure of the camera at the time it drove past a paint line at night. We understand how many lumens of light are being reflected. We know how visible those pavement markings are. And we collect that data for a fraction of the cost. Why? Because it's already being collected and made sense of by the drivers on your roadways today. That data is available to you to make sense of, to inform your striping efforts, reduce your cost, and comply with federal regulations. At the end of the day, the goal of the federal regulation here is to make the paint lines visible to human and automated drivers alike. But we can use it to inform your restriping efforts and reduce your costs as a secondary benefit.
All right, next question. How do AI autonomous vehicles identify the correct lanes in streets with snow if paint lanes are hidden? It's a great question.
It's a really, really good question. So a lot of this comes down to kind of natural variation, just like you as a human would, right? If the roads are covered in snow and you're the human driving down them, you're looking for cues, right? You're looking for guardrails, you're looking for barriers, you might be looking for pieces of the shoulder. Hopefully someone's driven ahead of you and put some track marks into the roadway itself. We're answering this question all the time. Part of our efforts have been focused on helping DOTs respond to their snow removal process, understanding which roadways are covered and which ones are not, where the pavement markings are visible and where they aren't. But again, this comes back to pavement markings. The core belief is that rumble strips will start to fade off, right? Autonomous vehicles don't feel rumble strips the way humans do. Replacing all rumble strip budgets in America with additional pavement marking funding in America may help fill that gap. At the end of the day, what we're looking to do is understand that. Vehicles are still looking and answering that question. Some of them will use radar. Some of them will use versions of LiDAR. Most of them will use computer vision, just like a human does, to get a sense for where they need to be. The vehicle might center itself on what it thinks the lane is, right? Until it looks for another vehicle coming in a different direction to get a cue as to where it should be in that infrastructure. The same way humans do, vehicles are trying to deal with this, and we will all deal with it in a slightly different way, given how much snow there is on the road and what the conditions are around us. So there's no easy answer, except to say, you as a local government or a state DOT have a role to play, and that's having clear paint lines. So as soon as there's a visible pavement marking underneath the snow, the vehicle can reorient itself about where it's supposed to be.
All right. Next question. For work zone detection, what is the latency between deployment on any roads and having that information available to an agency?
It's a really good question. The theoretical minimum latency here is 90 seconds or less from the time a vehicle passes a given location for that image to be uploaded to a server, for the images to be de-identified, work zone to be identified in that image, processed, and published to the work zone data exchange. That is an extreme that we have not seen anyone in the country engage with yet today. But it is the future, right? We know that smarter, faster, better is coming at us. Today, the majority of our end users will look at their work zones at the beginning of the day and at the end of the day. They'll look for opening of lanes and closing of lanes. They'll look to make sure their work zones are done, say, between 6 a.m. and 7 a.m. and between 3 and 5 p.m. to know before the morning rush hour and before the evening rush hour what the condition of their infrastructure is and how to report that to WZDX. But you could do this in near real time on your roadways anywhere.
All right, we have one more question for you. What is the vision for impacts to e-transport, helicopters, and drone deliveries?
Yes. Well, micromobility in particular and eVTOL is a key interesting application here. In the future, we see a connected mobility system that is not just vehicle based. Maybe it's a vehicle that has wings that pop out of it, right? Maybe that vehicle turns into an airplane at some point. Maybe that vehicle is equipped with drone blades and can become a gyrocopter. We see a variety of opportunities for these things to mesh together and become one ubiquitous ecosystem. It's telling that DOTs like the state of Utah have put together an air mobility group within the department to understand how these things connect together. But we see computer vision as being a core deliverable for all of these. We've consulted on projects where eVTOL companies are looking to understand if there might be something in the way of a landing pad, if there's debris on the landing pad, if there is a hazard that might be in the way that might not make it safe for that vehicle to take off or to land. We need to understand how these systems come together. And again, I think computer vision will be the key to doing that because these vehicles in the sky will be using cameras to understand what's going on around them. The vehicles on the road will be using cameras to make sense of what's going on around them. And those vehicles are communicating with each other. Through one centralized intelligence network, we can make sense of the entire mobility network, regardless if it's air, land, sea, or underground.
All right. Well, looks like we've run out of time. For those questions we didn't have time to answer, we'll be getting back to you via email. That concludes today's webcast. On behalf of Roads and Bridges, I'd like to thank Mark for his engaging presentation, ATSA for sponsoring today's event, and of course, all of you for joining. Have a wonderful rest of your day.